The panelists should be Ardeshir Gavan Sadeh from Tehran. He is not coming. We have Barbara Wallenberg here from Lübeck, who is an ENT surgeon. And we should have had Frank Riedel from Mannheim, but he is excused. He is at home taking care of his firstborn baby and wife, and he is replaced by his boss, Carl Herman. And we have Barbara Börtnes from Philadelphia, who is a medical oncologist, and Thomas Vogel from Frankfurt, who is a radiologist and interventional radiologist. He is not here either. And then it's only me from Bergen as well. So I think we will do this in 40 minutes. We will start up, I will say a few words in the beginning, and then Barbara Börtnes will come in and talk about something about the perspectives in the medical oncology field. After that, Barbara Wallenberg will come in and talk about the future with stem cells. And finally, Carl Herman will talk, is there any position or place for surgery anymore? After everything we have heard here. The perspectives, as we have, first of all, I want to thank the organizers with Reinhard Knecht and his co-workers for inviting us to this. It has been many hours today with heavy information, many good panels and statements, and tomorrow will be another full day. There will be perspectives. It should be both in radiotherapy with IMRT, etc., surgery we have heard and will hear more. Neoadjuvant chemotherapy is coming in and into the field, but it seems to be leaving it too, or in a combination with then chemoradiotherapy. We have molecular therapy, targeted therapy. We have heard very much about that. The kinases like tyrosine kinase inhibitors, EGFR inhibitors, VEGF inhibitors, COX-2 inhibitors, and we have also genetically steered therapy. We have immunotherapy that is not written up here, and we have HPV vaccination. And is the future perhaps instead individualized, tailor-made therapy? And it's a question mark. But the question is, how should we select the therapy? What we could also look at is not only organ sparing. When we heard the previous lecture here, or the panel about nasopharynx cancer, I think it's very much important to look at the quality of life for these patients and the function also of the organs that are involved in the heavy radiotherapy. And finally, what our administrators are looking at is the cost of treatment. Should we, and Pat Bradley was into that when we then did all this examination with CT, MRI, ultrasound, etc. Could we be more selective when we are looking at that? And there are even some shortcomings and obstacles in the future. There are certain restrictions in medical research and the ethical debate concerning use of human tissue and biobank laws. That may be an obstacle to overcome in coming years, especially for multi-center international studies. Head and neck cancer treatment is and will be a team therapy. It has been really emphasized here during the morning too. It is not a one specialty work anymore, and it needs a broader training perhaps of the people involved and also for the joint venture in the future. There is we need to have a knowledge in tumor biology, even the surgeons, pharmacodynamics, molecular genetics and modern technology in imaging, CT, PET, etc., and really the role of PET scanning, because it is quite an expensive examination. And we also, this is concerning both radiotherapy, surgery, and chemotherapy, have to, as I said, to be taken into account even for surgeons. In the future, perhaps a non-smoking HPV vaccinated world may, as I said here, hopefully change the incidence of certain cancers and may definitely change focus in head and neck cancer therapy. That is enough for the moment. There is one point more perhaps, and that is we need perhaps more advanced training in head and neck oncology. And that is taken up by the EUPHUS, and European Academy has discussed this as well as the UEMS ORL in Europe, that we need to be super specialized. So we need a 2-year, 1.5 year, 2-year training as the fellowship trainings in the US, even in Europe. We have to remember that Europe is a fairly large continent now with 450 million people. And we need to come in and have more training both in otology, otosurgery, otoneurosurgery, skull-based surgery, etc. And especially perhaps also when we are here in advanced training in head and neck oncology. They have it in some countries, but it's coming more and more. And I think that this will be something I will be working for the coming years, that we will have more of this post-specialist training. Now, Barbara.
You want me to start? So I noticed that the theme of this meeting is site-specific therapy or site-specific management. So for someone who does systemic therapy or targeted therapy, biologic therapy, the use of the anatomic site is actually a pretty crude surrogate for what the biology is going to be like. So we've known for a long time that nasopharynx cancers, which in many cases have a somewhat different etiology, are more sensitive to chemotherapy and radiation. In oropharynx cancer, we started to recognize that there was a subset of patients who didn't smoke and drink as much, and they seemed to have smaller primaries and a lot of neck disease. And very recently, Maura Gillison from Hopkins has described that this is a group of patients who seems to do extraordinarily well with induction chemotherapy followed by chemoradiation. So we are now in an era where we can put 3 pretty toxic chemotherapy drugs together for induction therapy. We can add cisplatin to radiotherapy. We have advanced, I think, in local control and distant metastasis control with our systemic therapies. And we're at the verge of a new era where we're interested in adding drugs like cetuximab, erlotinib, the VEGF inhibitors. We heard this morning something about the mTOR inhibitors, which I think are going to be of interest in this disease. And I am very concerned that if we run our studies in a site-based fashion, that we are going to miss the opportunity to figure out which patients benefit from which of these therapies. And we may either wholesale discard some therapies that are quite useful for a subset of patients, or we may end up in a situation where we're giving therapies that have extraordinary costs in some cases and unusual toxicities in others to lots of patients who won't benefit. So I think the slide that I found the most exciting today was one that Jeff Myers showed, and it was only based on about 12 patients, and I don't think that it's really a take-home, but they had taken serum from patients who were getting a specific regimen and had attempted, I don't know that we can say on 12 patients that the spread that he showed is really meaningful or we're sure it's going to hold up. But here were investigators who were taking advances in systemic therapy, introducing a new targeted agent, and then attempting to find a biological signature that would predict which patients should be offered this kind of therapy in the future. I don't think we're ready to do testing for large randomized studies based on biology in that way. But I think for the biologic hints that we have, and probably HPV status is one of the most important to date, we should be stratifying for these kind of factors in studies, and we should be very careful to collect tissue and serum for all the patients who are in the big randomized studies so that we can attempt to dissect out which not only stage patients or which subsite patients, but really which biology patients are going to be suitable for the therapy that we're proposing.
Thank you. The other Barbara Wallenberg.
Well, my idea, being invited to this meeting, was actually to really come back to basis of biology and think or reconsider what we're actually doing, because none of the therapies so far have led us very far. So the idea is to go back to the lab and screen for a new enemy. And the question is whether, with the upcoming knowledge of tumor stem cells, we have an enemy or a friend. So can I have the slides, please? So my idea was actually to look back and reconsider tumor stem cells and what's the difference among them, and what are we actually facing in clinic with these cells. Next. The theory, actually long-time theory of tumor development, was actually a stochastic model where all the tumor cells will be from one clone, each daughter cell being the same like the mother. So clear clonal development. But the new knowledge actually is that there's a hierarchic model which has a whole bunch of cells, which is the differentiated tumor cell, which is a tumor, yes, a pointer, that would be very nice. Thank you. Which is a tumor cell, which is the red one, is a tumor precursor cell, which could become tumor or would actually sustain tumor growth. And it's a tumor stem cell, the yellow one, which is actually the original tumor initiating cell. So the key to what we face in clinic, which is a chemo and radioresistance in basic and recurrence run by this failure to therapy, is actually we do have a complete selection of cells that are undergoing this type of therapy. Some of the cells will be lost, some cancer cells will die and will be eliminated, but some of the cells will remain, and predominantly those cells will remain that are able to completely initiate a cancer by themselves. And so the cancer stem cell will survive, and then a new cancer will arise just by one of these cells being completely able to restart the system. So the question is, how do you identify this enemy? And the enemy has actually been identified for head and neck cancer by Prince et al. It's a PNAS journal published in January last year. And he was actually able to describe a cell population of CD44 positive, lineage negative cells, about 10% of head and neck cancer cells, that would be per se isolated and taken into a mouse model, be able to restart the tumor completely, same image and phenotype like the one they've been taken from. So he could clearly show that one single cell would be able, with this characterization, to differentiate and completely self-renew the whole cancer from beginning on. We've been in this field as well, long time, together with Rita Young from now South Carolina University in the States. And we're able to show that there are also stem cell marker-carrying cells actually classified as progenitor cells, progenitor stem cells. And these cells would be able, they are actually actively driven by the cancer back to, the cancer releases substances to drive these cells from the bone marrow to the cancer. And he uses these progenitor cells, which he calls to himself, to build up his vascular system, because these cells are vascular endothelial cells all of a sudden. And these vascular endothelial cells by themselves are immunosuppressive. And we can show that these cells drive tumor inflammation. So, again, actually, basically a stem cell progenitor, which would be a friend to renew systems, all of a sudden turns into an enemy run by the cancer. What we don't know so far, but which is best known for lung cell cancer, is actually that bone metastases occur by a tumor cell invading into the bone marrow and finding bone and best situation, fuse with a stem cell which is in the bone marrow, and cause a bone metastasis by this event. We have no evidence to date that this might happen in head and neck cancer, but so far we might not have run enough trials. So the idea is actually, we do have a new type of enemy which we're focusing on, and there are many, many questions remaining, because this would actually also could give a clue to therapy then. We don't know what attracts stem cells to tumor in complete division yet. We know there's some cells homing, called by the tumor to come to the tumor, and he uses them to build new vessels, by example, but other systems also. We don't know what the niche, the stem cell niche milieu in the cancer would be like. We've too little insight.